So in this video we will see some numericals related to uncertainty, significant figures and precise measurements. So here is the first numerical problem, example 1.1. The length, breadth and thickness of a sheet are this and this centimeter. These two are in meter and third one is in centimeter. Calculate the volume of the sheet up to the appropriate significant figures. First we will write length, breadth and thickness. Given we will convert it into meters by dividing it with 100. We know that volume is equal to length, breadth into height. The product will be answer 7.14 exponent minus 2 meter cube, as we are given here to report it up to correct significant figures. So we will see from these three factors 3 significant figures 2.105 and 1.05. As the factor 1.05 centimeter from the 2 has minimum number of significant figures equal to 3. Therefore, the volume is recorded up to 3 significant figures. According to rule, we will record the volume of up to 3 significant figures because the least of these three factors, length, breadth and thickness, has 3 significant figures. So we will report our answer up to 3 significant figures. Here was 7.1457. As we are going to report it to up to 3 significant figures, we will see the next significant figure according to rules which we discussed in our previous video. If there is a 5 more than 5, we will round up or increase the previous digit by 1. So we have increased it by 7.15 exponent minus 2 meter cube. Next problem example is 1.2. The mass of a metal box measured by a lever balance is 2.2 kg. Two silver coins of mass 10 point this and this measured by a beam are added to it. What is the total mass of the box cracked up to appropriate seal? Now I will give the appropriate mass up to total mass of the balance up to significant figures. When we will add these three values, we will definitely give the total mass of this beam balance or of a metal box on a beam balance. We will see the least number of having factor the least significant figures is 2.2, which is having only one decimal place after the point. So we will give the answer our up to only one decimal place. Thus the total mass is equal to 2.2 kg. In this way you can report your answers in the appropriate significant figures. So this was example 1.2. Now we will see example 1.3. The length and the diameter of a metal cylinder with the help of vernier caliper of least count 0.01 cm or 1.22 cm and 5.35. Calculate the volume of the cylinder and uncertainty in it. We are given the data with least count 0.01 cm and length. Absolute uncertainty. This least count is actually equal to absolute uncertainty, as we see in our previous video. Percentage uncertainty we will get. How we will get percentage uncertainty? When we will divide this uncertainty with given length 5.35 multiplied by 100, we will give a factor 0.2%. Absolute uncertainty in the diameter is given as 0.01 cm. Same, we will apply uncertainty percentage for diameter as well. It comes out to be 0.8%. We know the volume of cylinder is equal to pi d square L over 4. The total uncertainty in volume is equal to 2 times percentage uncertainty in diameter plus percentage uncertainty in the length. So when we have already calculated these two values, percentage uncertainty in diameter and length, total uncertainty is equal to 1.8%. When we will put the values over here in this formula pi d square by 4 L over 4. We will given with answer as 6.2 centimeter cube as a volume with having uncertainty 1.8%. So 6.2 plus minus zero point 0.1 centimeter cube is the uncertainty in it, and 6.2 centimeter cube is the calculated volume. So this is from this example 1.3. We will see next topic of this chapter and the last one, dimensions of the physical quantities, in our next video.